Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Before I introduce today's guest, let me tell you a little bit about the podcast. So we started Data Unchained over 100 episodes ago, talking about the need to use decentralized data in lots of business, research, and government use cases. And yet, historically, the way these architectures were built out, it was very difficult to access that data. The data coming off of sensors and cameras, different cloud regions, different storage systems, were all really isolated and siloed, and yet we were trying to put them together into useful business outcomes. And with the evolution of AI, this has become even more urgent. AI models, AI agents are hungry for this data, and yet a lot of our systems weren't designed to aggregate this data and really make it simple to get information out of it. Data Unchained digs into some of the challenges around accessing decentralized data, some of the business outcomes you can get if you wrangle this problem into submission, and then also some of the solutions, the technology, the best practices, and use cases that are evolving, honestly, day by day in this rapidly changing market. So without further ado, one of the people that is honestly right in the middle of the technology evolution, the customer deployments that are happening in this space is Wendell Wenjen of Supermicro. Wendell, welcome to the show.
Thank you, Molly.
And Wendell, I think before we jump into the deeper tech and what's happening now with AI right now, maybe just give us a little bit of background. What brought you to Supermicro and the position you're sitting in and the center of AI storage today?
Yeah, sure. I've been in the technology industry for over 30 years, the last 3 of which have been at Supermicro, where I'm the Senior Director of Storage Market Development, which means that I do the product marketing for all of Supermicro's portfolio of storage platforms, as well as do all the go-to-market with partners such as Hammerspace. So it's been great to work with you and your team. And I also do all of our go-to-market with AMD for all of our data center and enterprise products in vertical markets. So that's been a lot of fun and very interesting. The things we're going to talk about on this podcast that are forward-looking will be my own opinions and not those of Supermicro. And then prior to that, I spent 5 years at Seagate, where I also worked with Hammerspace and you and your team on alliances with the systems group. And just overall, I've been working on the silicon side of enterprise hardware at Intel for 10 years, 11 years doing product management for processors, chipsets back in the early days, go all the way back to launching 46 servers for Acer. So that's going way back. I think my original job when I got out of graduate school studying engineering was I worked for Hughes Aircraft, which was the company that Howard Hughes started as a software engineer in the command and control systems area, and so we were developing real-time systems for air traffic control and radar tracking. So a lot of very interesting problems. And I ended up having one of my jobs and kind of developed some expertise in databases, designing the database for the database schema, right? So for the Canadian Air Traffic Control System, which was a very large schema, several hundred attributes and thousands of several hundred entities and thousands of attributes, which captured all of the static data. So I think nowadays that would be called an enterprise data architect. And we were implementing this. This is a long multi-year project, and so it really helped form my experience in designing and kind of implementing these very large scale data focused projects. And then, since then, and I went after that, I went to business school and studied marketing, but have always had some relationship to data. Even the 8 years I spent in the ad business, I was actually selling and buying advertising targeting data. So, which was a little different use of data, but still kind of related.
Yeah, and certainly mission critical. And when we look at the data that you guys are putting together, it's a lot of the foundations of that, so kind of how people started to think about real time insights from data and machine learning and AI. Is I think some of these are those precursors of what a lot of enterprises are trying to deal with now, but with a lot less experience working with these complex data systems. So it's great background. So at Supermicro, tell us a little bit more. Kind of, what are you all doing? I think most people know you as a great innovator in hardware and systems. But also, I think anybody who's read the news knows you're kind of in the middle of a lot of the really big initial foundational model builders, infrastructure build outs. Like, what is the strategy at Supermicro right now in AI?
Yeah, so Supermicro has been around for 32 years, and you kind of really started as a motherboard company and sort of evolved into a server system company and then a full rack solution company. So, fast forward 32 years, we're at the point now where these solutions are really delivered at a gigantic cluster level, especially around GPU computing and neo clouds and large service provider implementations. So those are a lot more complicated. They require sort of co-designing of the architecture, our software installation, just the on-site services to deliver that are quite extensive. The networking, so that is something that the company's really been focused on under a kind of a initiative or a family of products called Data Center Building Block Solutions, which really combines a set of services for these large operators through the design, our factory testing, the on-site installation, and then really the important thing, and I think what's really benefited the company was that it was Supermicro was very early into um, uh, the conversion from data centers from air cooling to liquid cooling that happened a while ago, and so the company really developed a lot of its own internal technologies, not just around the gold plates that go onto the CPUs and the GPUs, but the overall end-to-end system that has pumps, condensers, cooling towers, and we don't do actually the plumbing, but kind of all the other equipment as well as monitoring it. And now that we've seen a lot of these new GPU clusters only work with liquid cooling, it's been really important. Now we haven't really gotten to that need yet with storage. It's still not the biggest driver of power and heat dissipation, but it is, I think, in the future for storage. We actually kind of can see that happening, and we've seen some vendors around the SSD start to experiment with putting cooling jackets around SSDs, which are starting to take more power, especially when you have dozens of them in the same box.
It's interesting. Think about liquid cooling seems new, but now we're talking about putting data centers under water, data centers in space. There's definitely going to be a lot of evolution on the hardware side for all of us, whether it's network, storage, compute, as we keep trying to figure out how to power and cool these big systems. And it's really interesting to see how it's coming to fruition. So let's jump onto the storage side.
Yeah.
So initially, AI and a lot of the really big systems that were in the news a lot, were focused on building the foundation models, training these big models that are now more in mainstream. But as as AI starts to shift from training to inference, how do you see the demands on storage changing?
So at the recent AMD launch, Lisa Su had some data where they're seeing the AI workload moving from training to inference in about a 60% inference, 40% training kind of split. And it really does bring up a completely new set of problems for inference. And so one of the things that I think the whole industry is working on is with inference, you have the process of um, using prefill and decode as two phases of processing the query, and a lot of that can be especially the prefill part, can be reused from previous queries, especially things that are very common, rather than recalculated. And so I think the industry is moving towards special types of storage for that, very fast storage for that data, which is commonly called KV cache or key value cache, and using all flash. We've seen very large scale implementations, like full rack solutions that are going to be very high performance, but quite expensive come out. And I think a lot of different vendors are working on those solutions at different scales. It's not really been shipped in a lot of a lot of volume yet. I think the move, we'll talk about sort of the adoption of AI, but the move to large scale inference, particularly around the enterprise, is still pretty early. And so these large scale systems haven't really been or are still in development by a lot of the partners we work with. And so there's still a bunch of unknowns about the best way to do this and whether it requires data protection or not, and sort of other factors. But what is really exciting, I think, as a supplier of all this equipment and working with software companies like Hammerspace, is it's a new area of storage. It's going to be all greenfield, so it's not like something you can reuse that you have existing in your data center. And not only that, but I think enterprise AI, and enterprises are sort of still in the early stages of this, although they have of aggregating all their data so that they can apply all of their internal data to the AI workloads they want to run. And we'll talk about a lot of those aspects, but there's a lot involved in there, and a lot of that can be aggregated in like an enterprise data lake. And a lot of companies have been doing that for a long time, but some of them are little sort of older technology, for example, like using Hadoop. And these newer style ones using object storage have a lot more flexibility in them, and we're starting to see a lot of good adoption around that. But that it's not just a matter of buying the storage and buying the software. There's a lot of work involved in that migration and aggregation that was kind of similar to sort of the enterprise data modeling work I did early on for air traffic control, really understanding the schema of your data and understanding the relationships and being able to normalize that data. So a lot of work to be done. That's really, we'll talk about this, but that's, I think, one of the really long poles in getting enterprise AI adopted in a widespread way.
I definitely think you're right. It's like the enterprise they've needed to, receive the technology, build budgets, build plans around it. Certainly just getting the skill sets up and running to run these types of environments, a lot of enterprises had to build out. But when you think about whether it's inference-based storage, the build out of KV cache, do you see that storage will become kind of a major focus in budgeting and the strategic outlook of these companies? Before it was all about the GPUs, who had the GPUs, who had the largest farm of the latest and greatest. Do you see storage becoming more strategic?
Yeah, we definitely see that, and I think for a couple of reasons. So one is, and I know you've talked about sort of the cost of storage with other guests on your podcast. That's going up. So storage is, in the past, storage maybe has been 10% of a GPU cluster in terms of the overall cost. That's going up just mainly because the cost of the media, the SSDs and the disk drives are going up. But the other reason that we're seeing the need for different tiers of storage, different levels of performance, which is actually one way of sort of mitigating those cost increases. Actually, as an aside, is that with inference and having enterprises applying their own, what they would call their own sovereign data, their own internal data. A lot of them really don't want to export that data out to a public cloud or a public a neo cloud. We've heard from a lot of companies. Maybe they'll segregate their data into different labels of sensitivity. So there's some that they would be happy to do public cloud AI on, and some they're just not able to take their sensitive or PII related data, personal data with, let's say, personal information on, say, their clients or patients in healthcare, things like that, out to a public cloud. So there's a lot of reasons for keeping AI on-prem, keeping all the storage on-prem as well. Another one of them, beyond just the sensitivity of the data, is just cost. And we've seen enterprises that are running the models on-prem are able to cut the cost around half of using these frontier models. And so they might use a routing scheme. We heard a presentation from AMD where they use like an open router kind of intermediary to route more complex queries to a large frontier model. And then a lot of stuff, just like, say, your email assistant, they can do that on-prem.
I think how people are optimizing around cost, efficiency, like you say, while staying within their governance rules is really important. We hear a lot about power too, nuclear data centers being built just for, or power plants being built just for data centers. How does cost and power over time decline? I think maybe focusing on the power part for a little bit, that is this sustainable, or are there things in the compute as well as the storage layer that are becoming more efficient?
The way I think about it is if you look at the rack level, for a rack of GPUs, and you look at total power consumed by the rack, the total peak power, that's going up, and it seems to be on a trajectory to, typical enterprise racks are 10, 12, 15 kilowatts. We're definitely way north of that now with 100 kilowatt, 250 kilowatts, and I think that continues to increase. So what's really constrained is, in the short to medium term, is the total power going into the data center, right, supplied by the utility. And so you have data center operators going to come up with innovative ways of generating that power on site with generators or on-site power plants, or just finding locations where there's an excess supply of power that they can use. But the other way to really think about it is, what is the power per token, or power per result that you're getting? That is going down because we're really seeing that the token efficiency of a lot of these solutions is really improving, right? And because the GPUs are becoming much more performant. The storage is actually playing a role in that as well, by limiting the amount of stalls going into the GPU using techniques that have been around for a number of years, DMA, GPU Direct, and things like that. So there's I think a combination of these things. So overall power, let's say at the global scale, at the trajectory goes up. The extrapolations that I looked at a year or two ago, would, I think, one example was like total power being used by AI would be equivalent to the entire power consumption of the nation of Japan, and things like that. I think are not super sustainable. But so there's always going to be ways of finding more efficient, and so part of the I think the trend of this is the power per token. And perhaps you'll need fewer GPUs, fewer racks, fewer data centers to generate the same. On the other hand, though, on the other hand, the different uses of AI will be growing as well. So the demand for AI. So you have the supply side of how we're generating all of the capability. The demand side is another area that I think we're going to talk about, and that is the other part of the equation on how much power is going to be consumed if you just look at it from that perspective.
Definitely. The numerator and denominator are changing at the same time, right? So it's
Right.
difficult to predict kind of where we end out. But yeah, let's talk about that. So I think, I don't know if there's firm numbers out there, but Fortune 500 adoption of AI, especially like really running it in their business versus in a pilot or in a very kind of discrete use case, is still small. I don't know if it's single digit or double digit, but it's growing. What will it take to get to, like, let's say half of the Fortune 500 companies really materially adopting AI?
Yeah. So, I mean, I think that's really the key question, and what everybody's really thinking about, because in the long run, the biggest driver for large scale AI demand is going to be enterprise, and less so, the early users, which were consumers. And we've commissioned at Supermicro some studies and reports from IDC over the last couple of years about this topic that shows that we've been in this phase where enterprises have done a lot of POCs, and a lot of those POCs have not gone into production, right? So that's sort of a big gap. And in the early years, I would say a couple of years ago, that POC to production rate was not very high. It was in the sort of teens and 20s as far as percentage, and we're seeing that go increase now. But I think overall, to get to, I would say 50% of enterprises adopting AI in a meaningful way, which we would say beyond just one or two tools, but like a major functional area of the company really adopting it, say like sales or logistics or manufacturing or what have you. This is a topic that I've thought about a lot, and I kind of think about it in terms of a framework is a couple of frameworks that I've used in the past when I've worked on novel technology adoption. So, in the past, I've worked on in the early years of several technologies like smart TV advertising. I launched a service for that for LG in the very early days of smart TVs. Like after 1 year after they came out, we launched an advertising solution for brands and agencies, and then other kinds of new areas where introduced some new technologies for telecom. We're using Linux on x86. When I was back at Intel, this was in 2000 when Linux hadn't really been adopted in the enterprise or the core networks. And kind of the way I think about that is that there's a couple of models that are sort of empirical models in marketing to look at as frameworks. One is the Bass diffusion model, which is an equation that has a couple of parameters around the innovation coefficient and the imitation coefficient. And if you look at the cumulative adoption of any kind of technology, it can apply to telephones, to the internet, to AI. It does look like an S-shaped curve cumulatively. The other kind of framework that's similar to that, but it's also technology diffusion based model is Geoffrey Moore's model that's in his book Crossing the Chasm. So that divides adopters into phases, and this is really around B2B type of adoption, applying to new technologies that are novel. And he posits that there's this chasm between the early adopters and the mainstream adopters, and that's really what gets you across that chasm is kind of word of mouth. And what he means by that is that there's, as an implementer, say you're in your enterprise IT or you're in the line of business, and you want to know that your peers at other companies have done this successfully, and you don't want to be too far behind because that keeps put you at a competitive disadvantage. There's also some dangers, or people worry about being too far ahead. Maybe the technology is changing really fast, and you implement something and it'll be obsolete. So at the end of the day, technology adoption is really the rate of technology adoption is really based on human behavior. It's really, there's a lot of equations that can describe this, but what really is the main factors is human adoption. How long people take to make decisions, implement things. You mentioned training. Just things take a while to do. So having said all that, we're kind of in the early-ish phase of enterprise AI adoption, where we're beyond a lot of the generative AI POCs, but we are kind of in the POC phase for agentic projects, where I think there's going to be a lot of benefit to enterprises to be able to do these kind of long-running workflows and automate it as sort of infrastructure for the company or assistance for people. But I think the long story short on this, I mean, I personally see this as the big uptake at 50%, meaning you've got half of the mainstream adopters already doing it, and half the mainstream adopters and the late adopters not yet implementing it in about 2 to 5 years, I would say.
Yeah, and I think my experience, on the Hammerspace side really complements that. That's a great way to articulate it, that the first few deployments in any industry, whether it's quantitative trading or biotech or whatever it is, it seems like all their peers are looking closely at what they've done and how they've implemented it and which tools are they using to maintain, their data governance or security, whatever it is. And the whole ecosystem's kind of rallying around that so that we can build these reference architectures or frameworks for each of these industries to help them. And it makes sense to me that once those come out and they can share with their peers how they went about it, what their business outcomes were, things will take off a lot faster. When you think about, though, like use cases, and which are you seeing are moving fastest? Is it RAG? Is it knowledge management? Where are you seeing those early wins right now?
I think in terms of like horizontal workloads, the one that's really taken off is software coding, right? I think that makes sense in a number of ways. It's all text based. It is like having in the past been a software engineer myself. You can see a lot of the advantages of having a lot of the framework code being developed for you, or even the entire code. There's still a lot of work that the person will need to do to ensure this is functionally correct, and you can even have the AI help you develop all the test cases that you can run against this. But yeah, I think that's a very good fit for the capabilities of AI, and especially around where we are now. I think other sorts of things where a lot of the knowledge is already embodied in text thing. So code, there's giant code repositories on GitHub. Legal, on Westlaw, you have all the case law already in text is another one. So I think there's a number of these use cases that already are very are being adopted quite a bit already. Vertically, in terms of vertical markets, we've seen that capital markets trading are using AI in making trading decisions. So it's like for I just did a webinar with one of our partners not too long ago, and normally, especially if you're doing market making, where you're filling you're filling orders, which is a lot of what these hedge funds do, and you're trying to match the bid ask spread that the order is coming in. They're using very kind of simple predictive algorithms for that historically, and a lot of that's based on this sort of area called high frequency trading. Now they're really talking about mid frequency trading, where they're allowing more latency in the trade so that you can apply more of a complex AI into it, but hopefully make a better decision on the trade. So I think it's really evolving, and a lot of these industries that are certainly in capital markets, they see a direct correlation between their profits and how their infrastructure is. So if it works, they're going to spend more on it.
So when you look towards what these winning AI infrastructures are going to look like, kind of as this standardizes and gets established, I know you mentioned highly integrated architectures, and it makes me think about, some of what work NVIDIA is doing right now of things like AI data platforms. Certainly at the AI factory side, complete racks with integrated systems are coming about. But there's also reference architectures for each of these industries of how do you piece and part everything together for your vertical. What do you see this looking like as things get a little bit more standardized and established?
So there's sort of two things going on at once. So on the storage side, we've seen over the last 10, 15 years, the storage industry, as you know, having been in there, has really moved to a software-defined both a business model, delivery model, a development model, right? So where where the software, the storage software, the data management software is able to run on a variety of different hardware platforms. You're not locked. It's not really proprietary hardware. There's, of course, still a lot of testing involved in that, but there's a lot of flexibility there, and that really gives uh, a lot of ability for the vendors like us and like with you with Hammerspace to configure things for the best fit for the workload. For example, doing something all flash versus something with a hybrid disk and flash configuration. So that's sort of at the storage level, but then kind of at the bottom level. But then you see that you have sort of this bigger bigger trend around, well, storage is just one part of this overall data center solution. You have networking, you have GPUs, you have computing, you have cooling, and the big question in the industry historically has been, do we do best of breed or do we do these integrated solutions? And I would just say historically, the integrated solutions have generally won out in the long run as the preferred way. And the reason really is that simplifies things. You really get most of the benefits that way, rather than having to pick and choose everything. So I think that is kind of the long run solution. That's what we're seeing, trying to combine storage solutions with GPU solutions, with compute solutions, and networking, and deliver it as a installed solution where we just will come on site and roll it out over a couple of weeks, test it for you, and that just really eliminates as many complexities and variables as possible. So that's sort of the long run, but I think the storage piece of it is still very much software defined.
Yeah, absolutely. As we kind of tie up and point these listeners to where they can learn more, we touched on a lot of topics kind of broadly. You have an open storage summit that I know you personally are very involved with putting together. In fact, I think you may run kind of the strategy on that. But it pulls in a lot of Supermicro's customers, a lot of Supermicro partners. Tell us a little bit about that and where folks can learn more from that.
Yeah, so I've been running the Supermicro's Open Storage Summit the last 3 years, and this actual event has been going on over the last 7 years. So it really focuses, and like I said, with storage being software defined, it really involves hardware platforms. It involves silicon. We pull in the software providers for data management and storage software. We're very thrilled to have Hammerspace come back again as a sponsor of that. And then we also bring in, very importantly, the SSD providers and the disk drive providers, because each session really, you want to understand from the perspective of each of those parts of the solution: the software, the platform, the media, right, and the process and the processing. So we're very thrilled to have you as a speaker in two of the sessions. And overall, the Open Storage Summit is starting on August 11th. With the live broadcast and ending September 3rd. So we're going to have 12 sessions. This is very exciting. We're going to have 12 sessions. We have, I think, 44 speakers, 20 companies participating in it. We'll have a number of really interesting topics that really are about AI and how storage is being applied to AI in enterprise, in neoclouds, in CSPs. And you're talking in two of the really interesting sessions. So the sixth session you're going to be on August 20th, talking about enterprise storage modernization for AI, which is a great topic because most companies when they add new more storage, it's not like they're getting rid of everything that they ever had before. So this is a big challenge. And then the second session you're in, which is session 11 on Wednesday, September 2nd, which is managing unstructured data for AI. And this is also really key because we know that 80 to 90% of the enterprise data that's used in AI, and enterprise data in general, is unstructured, right? It's not record-based data in a database. It's documents and photos and things. So those will be really two great sessions that you're in. And the way to go and register for this event, it's being hosted by theCUBE, which is an analyst company that is producing it for us and moderating it for us. And their website is thecube.net, and you can find it on their homepage, and you just register for it, and then you can either watch it live we'll do 3 a week for 4 weeks, starting at 10 o'clock a.m. Pacific time, or you can, if you sign up, you just watch it on demand whenever it's convenient for you. So we're really looking forward to having those 12 sessions with a lot of great partners. We're so thrilled to have Hammerspace as one of our sponsors. And I know you guys have a lot of really informative things to say about how enterprises can both manage their unstructured data and modernize their infrastructure for storage.
Yeah, absolutely. And thanks for summarizing our sessions and the summit overall. I think you are in a really unique spot to bring together multiple vendors, so you, like you said, can get the full perspective: the software, the hardware, the media, the best practices different vendors are seeing. And I think customers, as you said, across the chasm, need to hear that so they can see what are others doing. How do you bring all the pieces together? So certainly I'm excited to be a part of the summit. We'll put links to theCUBE and how to register in the show notes to make it easy for folks to find as well. But Wendell, for now, thank you so much for joining the show. I will definitely point folks to your Open Storage Summit. As we tie up, is there any prediction you want to leave us with? Where will we be 6 to 12 months from now? Your crystal ball for AI.
Yeah, I thought about that, and I think sort of the best prediction is that we'll start to see a lot more implementation of these specialized storage solutions for inference, with especially for KB cache, starting to come out in the next year. So we're starting to see that being developed by our partners, and we're really excited to have those out in the market. And I think as companies really implement those enterprise AI solutions that are covering like meaningful parts of their business, they're going to need ways of efficiently handling their inference. So that's kind of the best view I have coming out in the next year.
Awesome. Wendell, thank you for taking the time to join us. It's great, as always, to catch up with you. And maybe we'll have you back in a year and see how your predictions came through.
That'll be great. That's fantastic.
Awesome.
Thanks so much for having me.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.